in case they missed. All right, so parametric modeling. For this one, we're going to start with the cube. And again, the cube is always the same height, width, and depth, and all edges have a chamfer that is 10 times smaller than the height. So in here, there it is. I'm going to start a sketch. I'm going to go boom. I'm going to click here, and I'm going to make a rectangle. This is where things, like, from the get-go get spicy. So I'm going to make one of these my driving equation, my driving force. So for the first dimension, I can really choose whatever I want. So just for simplicity, I'm going to say this one is 1, and then tab. And then right here, when it's asking for what dimension do I want to put here, you can just kind of drop it in. We'll edit this one like this. We'll put it in this dimension. It's going to say, what do you want it to be? And it's going to say edit dimension colon D1. So what happens every time you place dimension, it gives it a tag. So dimension, your first one is always D0. So it's the D, I like to think original, even though it doesn't stand for that, but because it's a 0, not an O. But you can link dimensions together. So if I want this dimension to be the same as this one, notice how this turns into an f of x. I click there, and I click check, and now this right here, it's a function. It's not just a dimension, it's a function that says whatever this is, I am equal to that. So if I change this one to like 2, watch what happens. Then they both become 2. Yes?
So after setting the first dimension, how did you select this?
So I'll go back. So the first one, I just did 1, and then I clicked OK. And then I added another dimension right here. And then I can edit it and just click that. It's pretty cool. Heckin' rad. So once you've got that, you can click check. So finish sketch. And then it's going to get even wilder because we're going to use an extrusion. And it's going to ask, hey, how far do you want this to extrude? And I'm going to say, I want it to be the same as this. So you can actually associate extrusions as f of x as well. So I can say, make this extrusion the same as this or this. Either one will work for this example. So I'm going to click, let's make it the same as DO, and click OK.
Wait, how to do extrusion?
So extrude, finish sketch, extrude. And then for the dimension right here, instead of giving it, or the distance, instead of typing in a number, I'm just going to click one of the dimensions that we've already placed. And I'll click OK.
So for to make the second dimension, the D1 a function, you click on the arrow, which one do you select afterwards?
The original dimension.
The what dimension?
The first one you did.
Oh, okay. So, and then that will automatically.
Yeah. Yeah, it should do it automatically. Okay, and then kind of as a fun thing, to check your dimensions up here, there's this thing right here called f of x. It's next to your appearances. This is your all your parameters. If you click here, it'll bring this table up, and this is keeping track of all of the dimensions that we've created. So D of O was in the sketch, D1 is in sketch 1, extrusion, D2 is an extrusion, D3 is an extrusion. So this just shows us how they link up. And the crazy thing is we can manipulate our dimensions in here. So if I want to make this cube 3 times as big as it is now, I can edit the original dimension right here and say make it 3, and it will size everything up.
Where do you select the parameters?
Up here. So you click parameters, and then you can change your original if you want to be like, let's make it 1.75 inches instead of 3, so it makes it a little smaller. Or make it 1 inch, so it's extra small. So it's kind of cool. So it automatically sizes with it. And so once you got your cube, you can X out of parameters. That was just a little sneak peek. Now we can highlight, actually we'll go chamfer, I'm going to highlight everything on here, so the whole thing, and it's going to say, hey, what distance do you want to do? And I can also type in parameters. I can use mathematical equations. So for this one, I'm going to say D0, D0 divided by 10. So it's a tenth. So it's always 1/10 of the original. So this is D0 divided by 10. Yeah, and then you just hit OK. And it should be good. It's the Tesseract. Sort of. And if you want, you can change the material, of course. I always like doing that. So I'm going to make this a nickel copper alloy. And so to test this thing, to make sure it works, that we've got all of our parameters right, we can go up here to parameters, the f of x, and if I change this, everything should size and scale proportionally. So I'm going to make this 2 inches instead of 1. Enter. We'll size up. I can get really crazy and make this 1,000 inches and break my computer, because now this thing is like, oh my gosh, 1,000. It's big. It's really big. Or I can make it 0.001. So now it's microscopic. Though when you zoom in, it doesn't look like it's any different. So it's been scaled. And if I just make it 1 like this, it's going to look like it's really big. So, yeah, kind of cool. Okay. All right. Anybody to redo any of those?
You just need to get a screenshot of it, right?
This one, yeah, I just want a screenshot. Yes.
The chamfer.
The chamfer. All right. I'm gonna just. Yeah. So you can wait through the screenshot at the end. All right. Chamfer. Delete. Okay. So to get the chamfer, I'm gonna go click the chamfer tool up here. I will highlight everything, and right here when it says distance, I'm just gonna type in D0 divided by 10. So the D0 that's the very first dimension we put in there, our driving one. Well, technically we could do D1, 2, or probably not 3, but definitely 1 or 2, and it would still work the same. And we can change it, or we can test it by going like this. 2. Sounds big. Pretty cool. Alrighty. So, for our next item of business, we are going to do the fancy bowl, which is always 3 times wider than it is tall, always has a fillet to make a curve that is 3/4 times the height, and always 0.25 inches thick. So this one's going to be a tiny bit more complicated. So what we're going to say is, so it's 3 times wider than it is tall. So I think the first thing we're going to want to do with this guy is, well, first we're going to open a new file, new part, and start a sketch. And then this one, what we're going to do is I'm going to make a cylinder. I think that's probably the best way to start with this. So I'm going to just draw this out here. And it's always 3 times wider than it is tall. So I'm going to actually have to go backwards a little bit. First, I'm just going to make this whatever size I want. And then I'm going to extrude it out a little bit. And I'm going to ignore the numbers for now. And I'll fix that in just a second. So it's always 3 times wider than it is tall. So I'll go into f of x right here. And D0, that was how wide we made this, so we can kind of experiment. So I make this 2, it should make it wider. Oh, no, makes it taller. Wait a minute. Huh. That's weird. There should be another one. Yeah, where'd it go?
I have this.
Yeah, I just had it and it like disappeared. Let me try that again. Weird. Huh. Well, If that happened to you, you can always go back into here and cancel. Sorry, I'm going to edit my sketch. Maybe it's because I didn't have this in here. Okay, yeah, so it's because I didn't put I didn't specify that one. So if that happened, just give it a random dimension like that. And then go to f of x. There we go. So the order's off a little bit, but that's okay. So if I change this one to 6, it should make it a little wider, or let's make it 3 so it's smaller. So that's the width, or its diameter. And then this one is the height of the extrusion. So the height is always is going to be the driving force. The diameter is going to be 3 times. So you go 3 times d. Oh, and it may not be d0 for you. It could be d1, d2. You just have to kind of play with it to make sure you got the right one. So now, if I change this to 1, it should scale. If I change it to 3, it should scale. Looks good.
What's the body? Yeah, what is the bottom?
What was that? What does this say?
Yeah.
Oh, okay. So good question. So it's supposed to just be 3 times, and then you can just click DO. Oops. Like that. And the UL in there, it will automatically update it. It'll say, hey, do you mean this? And it adds it in there. UL is an acronym for unit less. So it just means that this 3 isn't inches, it's not feet, yards, megaliters, or anything like that. It's just a number. So it just means a proportion or a ratio. And ratios don't get units. So this top one.
For me right here, the D2 is consumed by the extrusion. So
Well, I don't know about that one. That's a little odd. You can, let me see. Yeah, it might be, you might have a different, the incorrect link. Linked them, it might be backwards. So I might start that one all over again because that was a little confusing. So if you're like me and you started off this a little bit wrong, I'm just going to start it over. Okay, so if you're to start from scratch, so if you started from square one, start a sketch, drop right here, just make a circle, and I'm just going to give it a random number, so I'm just going to say it's 1 inch and say OK. So that's what I missed the first time. I forgot to put in this first dimension. Oh, and you know what? I just realized it's going to continue being kind of funny because, oh, no, it worked. Okay, good. All right, so then finish sketch, extrude, and I want this extrusion to be that one, so I can click on that original right there. And if I want the circumference to be, so the diameter to be 3 times the height, so when I put the height in here, it also stands to reason that I could do D0 divided by 3. That's another way to do it. So it's just the other way. There's generally more than one option to do the same operation. And yeah, so DO divided by 3, and click OK. Awesome. So now we have this tuna can shape. And the next one is to have a fillet to make it curve that is 3/4 of the height. So I'll come, oh, not that. I'll come over here. I'm going to go fillet. Click it there. And I'm going to say, let's make my radius. So I'm going to do 3/4. So I can either do 3 times the number divided by 4 or multiply it by 0.75. That's easier to do it. So I'll just say 0.75 times D1. Yeah. Because if I do DO, it won't work. So it should give you a preview that looks kind of like that if you've got the right dimension. And you click OK. And I can also check that in here as well. So if I try to size this up, so let's make it twice as big. So it'll make it that way. If I want to make it back down to the same size, like that. This is pretty cool.
Let me just take a screenshot of this.
Almost. There's still one more thing. So the last thing, I've got this kind of like Smarty shape, I guess. How can I hollow it out so it's more like a bowl? Yeah. Oh, you guys are geniuses. So shell, click here, and it's going to say how thick do you want the bowl? And this one does not have a proportionate one. It says in here that it's always 0.25 thick. Oh, so when we've got that, we just type in 0.25, hit enter. So when the bowl is really tiny like this, it might look kind of weird. So this is like more like a wooden peg top or something. We can change this again. We can go in and say, let's make this bowl 6 inches wide. So now this is more like a kind of like a smaller soup bowl. Looks pretty good. And if you really wanted to get crazy, you could also add a fillet on this edge and this edge and just make it 0.125. Don't have to do this. I'm just being picky. And it would look like that. So kind of cool. And then you can size this indefinitely. So now let's make this thing a bathtub, like a pool size. So let me see. That would be like, let's try 600 inches. Mega bowl. So you can go swimming in that thing. It is very thin. That would be a very thin wall for a pool. Yes. I'm sorry, the what? 0.25. All right, so I'm going to make this smaller again because that's a really big bowl. Let's say just a standard, let's say it's like a salad bowl, so it's 12 inches. Meow. No, it's tiny. So, kind of cool. And you might get this, notice how my graphics kind of got weird there for a second. Sometimes that happens when you're sizing things back and forth. And that's kind of normal. Because if you zoom in just a little bit, it'll go away. If you zoom out, it comes back. It's weird. I don't know why it does that. So, okay. Alrighty. Yes. On the outside edge, this one? Or on the top? Both? Okay. I'm just going to undo a couple of steps here. Okay. And okay. So you've got this shape. So going back to here. So you go fillet and you click this edge, and this one is going to be 3/4. So you just do 0.75 times D0. Or 1. Yeah, D1, sorry. So if it doesn't work, then just change the number. So I tried D0 and it failed. So D1 was the correct answer. So 0.75 times D1. And then OK. And then you can just hollow out using shell right there. And a thickness of 0.25. Click OK. And then if you really wanted to, you could also do a shell there and just make it 0.125. And we made a donut on accident. So we can make it bigger using FX. 6 inches. That looks better. Okay. Alrighty, well there's your bowl. So the last one is the gear. And the gear is fun. So we're going to go File, New, Part, Create. Okay, so the gear must always have, so the center hole right here must always be 0.25. And this is a pretty common application because generally gears all have the same axis or the same axle, or, well, a lot of them will. And then you might want to just change the size of the gear itself. So this one, it doesn't say exactly what spacing it should be. It should just be equal. So this one, they all have 20 to 24 teeth on it. And the teeth should be distributed equally regardless of the diameter. So what we're going to do is, with our part, we're going to say start new sketch. You can use any plane, really works just fine for this. And I'm going to make one circle right here. And this one is the inner diameter, so I want to make sure that this one has a dimension. What did it say? 0.25. So this is, oh, come on, Inventor. So I'm going to click here and I say 0.25 as this first hole right here. And then I'm going to make another hole, or another, diameter that comes out like this. And this one's going to be kind of our driving one. So I'm just going to, let's just call it 1 inch and say OK. And finish sketch. So this is going to give us kind of a wheel shape. And I'm going to extrude this. And it doesn't actually define how far we should extrude it, so I'll let you choose. You can do just kind of something that looks proportionate, so a little bit more like the image where it's a little smaller or thinner, so like 0.25 maybe. Or you can do something really massive. It's really fine. Either way is okay. And you'll click OK. So you should have something that looks kind of like this, and it's wonderful. And once you got that, we will go sketch right here. And this is where we're going to put one tooth, just one itty bitty tooth. So I'm going to say, I'm going to use rectangle tool, and I think the best one for this is the 2-point center. So rectangle 2-point center.
Where do we go to start sketch? Like which side do we do it on?
Just either flat side.
Okay.
And 2-point rectangle. So I'm going to click right here. And the first place we click is going to make it's going to start in the center. I'm going to come out like this. And it doesn't define how big it needs to be, so we can just kind of choose. So I'm going to say, let's make this guy, let's just try 0.1 by 0.1, so it's a 1/10. And that looks great. Or maybe even, and this one too, like there isn't really a right or wrong answer. It's more just like, oh, that was not right. Take it back. There is a wrong answer, and that was it. 0.05. So I just did mine 0.05 by 0.1. So just a tiny bit smaller, and then I'll say finish. And this one, you can do it whatever size you want, just as long as it looks.
So you do 0.1 on the side and 0.25 on the bottom.
0.1 and 0.02 or 0.05. It's hard. It's really hard to read it, I'm sure, because it's so small. 0.05, 0.1, and finish. And then this extrusion, we're going to go extrude. I'm going to click this space, and I want to extrude this. There's a thing right here where it's so I can flip the direction so it goes that way. And then right here when it says distance A, if I use this second arrow right here, it's going to say 2. And this is a really useful one because instead of trying to measure this out every time, I can just say, let's go 2, and then I can click on the surface I want it to extend to. So I'm going to go from here to here, boom, and click OK. Sweet. So now we've got one nice tooth. Our little gear is growing up. Started teething last week. The first tooth is popping out. Man, It's truly pretty, just awe-inspiring and really a heartwarming thing.
Can you outline it one more time to make sure I got it right? Because it doesn't look right. Like it looks like it's gonna like cut a hole in it.
Oh, okay. So if it looks like it's going to cut a hole, yeah, so it's going this way. So let's say I highlighted this part too, so the whole thing, and that's okay. You can do it this way. If I flip the direction, it might look like this, where it's like, oh, I'm going to cut a hole. If that happens, you change the Boolean output right here, and you change it to join, like that. Yep, join, and it should look like that. Look okay? Yep. And now, this is where we're going to start using our parameters. So there's a handy-dandy tool for making more than one copy around in a circular, circle pattern. So I'm going to click circle pattern up here. It's kind of next to this purple Thanos cube. I'm going to click that, and then I'm going to click either this extrusion right here, or I can click it over here, either way. And then it's going to say, what's our rotation of axis, or rotation axis. I'll click the right arrow, and I can click this outside surface or the inside surface. Either one will give it the axis we need. And a third option, you could actually click this axis that's going through the middle of it. It'll show up right here. So mine's the z-axis. It might be different for you, but I almost always just use this because it's easier to find. All right. So now it says that it's going to say let's make 6 gear teeth. We actually need 24, and we'll click OK. So that should make a whole bunch of teeth like that. And the cool thing about this one, if I go into f of x now, and D1 is my driving one. If I change this to 2, it'll get bigger, but the teeth stay the same and the spacing is the same. So it's a really cool way to manipulate all of this all at once. And if I make it really small, so make it like 0.5, those have a ton of teeth. And technically that wouldn't really work, but it's still cool. 0.75 might. Yeah, that probably would work. And if I made it really big, could do 2 inches. Well, it's not really big, but. And one problem with this, like this works, and you don't have to do this. I'm just going to give you guys some extra sauce, just a little extra cred here. So if right here where it says number of teeth right here, I can do this. I can say that the number of teeth is dependent on this diameter. So I could say that the number of teeth is D1 times, let's say, 12. So then that'll just make us a bunch. So I think if I go in here and I change this to like 1, then it'll have 12 teeth. So that's another way to do it. So that this will give you more than 24 teeth. But this makes it possible to have a gear that always has the same mesh, or the same fit with another gear. So I do 13, then I'll give it 26. Oh, actually, nope, I was wrong. If I do 13, so here's a huge one. But I meant 3. So, yeah. So then I'll have 36 teeth. So pretty cool. That's another way to do it. So if you're ever custom making gears, this is how I'd recommend doing it. Yes? The width of the gear? Is that what you're asking? Oh, You can. That is possible. So for the assignment, you don't have to. But if you did want this inner diameter to change, I could make this one dependent. So actually, I'll make this smaller really quick. Let's say this is just an inch, so it's 12 teeth. If I want this right here, D0, to be dependent on the overall size of the gear, I could do that to be, let's say it would be D1, so D1 divided by 4. So it's always a fourth of the overall dimension or size. So if I go in here and change this to be 2, then it will size up like that. So it'll stay proportionate. Or if I make it 3, it's pretty cool. So it stays proportionate, but the number of teeth changes depending on the size. So the only con to this, notice how this one is red. I think if I do a weird number like a fraction, it might not work. So if I say let's do 3.3 or 2.3, it'll get kind of weird, and it's going to make yeah, actually I'm surprised it worked as well as it did here. It might change it to the nearest whole number to make it work, because decimals, it doesn't like that. So I could try 6, so it's really big, and that will remain the same. So it's pretty cool. This has always been pretty fascinating to me, and this is what professional drafters and 3D modelers will use, because if they ever find like they're doing they make an engine or something, and they realize, oh, the engine needs to be 10% larger, rather than going in and modeling every single piece 10% bigger, they can just go in and find one dimension, multiply by, like 110, so it's 10% larger, and then everything scales up. So it's really, really, really useful, and it saves a bunch of time. It does take much longer to set up, but in the long run, it's a time saver. So yeah, and I don't expect us to do this for everything we model from here on out, but this is just something we cover as a part of did you know? And this is what they do in industry. Okay, so once you've got all that, I have a lot of things open, so you're going to see a lot more than just this. But if you double click the gray bar right here, it'll open up everything that is in your panel. This is actually a sneak peek to an upcoming project. But we basically just want these 3 right here. Snipping tool, new, want that, and you'll just turn that in.
Wait, what the?
Yeah, sorry, all this other stuff that's stuff I'm working on for something else.
Okay, how do you get to there?
So you double click on the gray right here, and it will open up everything, which is really nice. Makes screenshots a lot easier. Okay. Alrighty. Well, that's a wrap, folks. So I will cut the timer